Welcome. Thanks for joining. So we're going to talk about production-ready GenAI with open models for Java teams. I've got a lot of materials to cover here, actually, and a bunch of demos. We'll see how far we get for the 50 minutes. So we're going to talk about why open models, cost, latency, and IP control. We'll talk about the model landscape, the different models you can use for open source, model selection, integrating open models with LangChain for J. I've got some demos for that, and integrating models and running models with Ollama as well. And we'll talk about, I'm going to show a demo of vector search, and then talk about different ways you can deploy things as well. So just a show of hands here. How many people have used or know about Hugging Face? Okay, quite a few of you. For those of you who haven't heard of it, don't worry, I'm going to show what it is, and we'll talk about that in a little bit. It's a great place to go and get open source models, but we'll talk about that later. Let's dive right in to talk about why enterprises would choose open models. So everyone started with ChatGPT and equivalent tools, and those are out on the cloud, of course. But the need to actually build your own models has grown over time as people get used to working with large language models, and they have proprietary things they want to do. In fact, I was just at the booth and someone was talking to me about what do they do with all the information. They want to save all of the prompts and all the interaction they have when they're actually building things. And how would you save that and organize it? And my thought was, you could have an open source model and you could train that model on all the prompts that you've developed over time. And then you could use that model to ask questions and say, hey, the last few prompts that we used for cloud, use those prompts and integrate those into a new prompt with a bigger model, and then take that prompt and put that into my small prompt open source model. So that's the kind of thing you can do with it. You can work with things locally. It manages cost. It manages latency, so you don't have to go out to a network, or you can control which network you're going to. And you have IP and data control as well. And you can fine-tune and customize your open models. Here's a great example, actually, of something that I saw recently out in the news. AT&T had 8 billion tokens a day they were using in their organization. And so what they did is they actually did orchestration, which means that before any large language interaction happens, the first thing that happens is you go into a router or an orchestrator, and that orchestrator or router has an agent inside it that decides if this needs to be queried in a large language model. And the large language model can be on the cloud, or it can be a local large language model, so you save a ton of tokens that way because you're not being charged for every token that you use. So they actually cut their cost by 90% by using a combination of routers that did things. You know, if you ask what's the weather tomorrow, that you don't need all the knowledge in the world in a large language model to go out and get what's the weather tomorrow. You can go out to weather sites and get it. So the router could send it to the weather site instead of asking a large language model. Also, you could have local models, open source models that have been trained on specific data inside your org, and those can be routed to be used instead of some big model out on the cloud. So that's just one concrete example of the way people have saved money and basically help with latency and customization and control their IP. So open model terms, these are things we need to know. These get thrown around a lot when you're working with models in general. And I don't think everyone knows what they mean, really. I'll be honest, I didn't know what GGUF meant. So quantization, basically the whole idea with that is you've got these quantized models that are basically smaller. They're reduced. How are they reduced? They're reduced by taking high bits, which the data is stored in, and basically compressing it into smaller bits. You lose a little bit of precision when you do that, but in general, the quality of the responses, depending on the purpose that you're using the model for, can be similar or the same. So that's what quantization is. It basically just decreases the memory usage and file size for a model and allows large models to run on consumer hardware. You don't always need a GPU when you're using models. If you're just doing inference, you're not doing any kind of training, a regular CPU or an ARM processor sometimes will do the job. So that's a good thing to keep in mind. And you can use quantized models to basically save some energy and space as well. So GGUF, it stands for GPT Generated Unified Format. So a lot of models create this thing called a GGUF file, and inside of that file is the weights, the architecture information, and the metadata all in one file. So when you download the actual model, you're downloading a GGUF file, and that can be used with Ollama and other tools that sit on top of that to interact with that particular model. MOE is mixture of experts. So what you do is you basically, it's almost like sharding or splitting up your model into different segments. So different segments have different tasks. So part of your model can be for routing, as I mentioned before, for orchestration and routing, or another part of the model can be for language translation, or another part can be for math computations, things like that. So when you do that, the research shows that you can have similar results to larger models. So quantized models that have a mixture of experts in them can perform almost as well, depending on the task, as some of the bigger models out there, with much less memory usage, much less energy usage, and similar performance. And TTFT is something that the model folks talk about a lot. There's all these weird benchmarks. Everyone's seen those benchmark names that don't really mean anything except to the person who created the benchmark. But this one is consistent across all models, TTFT, so time to first token. That means when I send a query, when I send a prompt out to a model, when do I get the first token back? So that's a way of measuring the performance of your local models, or any other model for that matter. Okay, and open source and open weight models. This is an important distinction, and I think they get conflated sometimes. So open source models have everything open source. Full transparency, including training data, code, everything. It includes the training data that the model was built on. And that can be used for auditing, retraining, and full, basically, reproduction of the model. And then there's open weight models. These do not include the training data, and in some cases they don't include the code. They only include the weights. So it's just the trained parameters, and they give you access to those trained parameters, but not the original training data that they were based on. And those are good for local use and fine tuning, but you can't completely reproduce the original model. And they're great for inference, basically, and or fine tuning. So the difference between inference is you're just using a model without any kind of training at all, and fine tuning is you're taking the current model and adding a bit of training to it, not a lot. You're not completely rebuilding the model, but you're just adding a little bit. Let's say you have a Java model out there and it's open weights, and you just add Java 26 to it. That's fine tuning. So you just add a little bit to your model. So the open model landscape, there's one that didn't make it on this slide because it just came out 5 days ago and I didn't get time to add it. But basically there's the Llama family, Mistral, Phi 3, and Gemma 2 from Google, and Qwen models as well. Those are all out there. They're available. They have different sizes and strengths and different purposes, really, and different licenses. And the one that's additional to that is NVIDIA just came out with a very large model called Super 3. I'm going to show that in a bit as part of my demos, but Super 3 is a 120 billion model. It's much bigger than anything here, and it's completely open source, and you can use it for, open weight, and you can use it for inference and for fine tuning. So pretty cool model as well. So at the moment, I don't know if it runs through Ollama at the moment, but we'll keep the questions to the end if you don't mind. Sorry, that's okay. Yeah, I can check that actually. I'll check it when I go through my demo. I'll see if it's there. Yes, basically selecting the right model for your use case, define your task, whatever you want to do with it, set your constraints, and that includes GPU and memory, and then benchmark candidates on your data. So there's public benchmarks you can use, and you can use those as the starting point to actually benchmark your models. And definitely consider quantization if you have access to that, and basically it reduces memory with minor quality loss. See if that's going to be good enough for you. And then evaluate trade-offs. You can start with a smaller model and build up to a bigger model. That's probably the best way to go to see if it gets the results you need. And then plan for rollback. So if the models change, make sure that you've got version control implemented. What to measure? So quality measurements, task accuracy. Here's some of the benchmark names I was mentioning. MMLU, et cetera, et cetera. Basically, does this meet your quality requirements and performance metrics that you have? And is RAG retrieving data, is it grounded? Does it maintain faithfulness, which means grounded, basically, when you're building the models? And then make sure that you've got an evaluation set that you can use across models to compare. And check models. You can actually set up some eval questions that will generally induce hallucination. You can see if it's going to happen on your model as well. And then there's safety and toxicity scores to check as well. And performance metrics, time to first token, I mentioned before, tokens per second, latency, and CPU and GPU memory, et cetera, et cetera. So, in general, the large models are what you would expect to be. Then they basically start at small with less quality and grow as the number of parameters grow inside of your model. So 70 billion plus is a big model and will give you the results you want, but it might not be good in terms of memory usage and what you actually need it for. It might be just way too much than you need it for, basically. That's the whole point of this slide here, is to make sure that you've got, the tip at the bottom is the key. So start with the smallest model that meets your quality bar and then scale up if you need it. So it's all about conservation, really. And working with JVMs in Java, don't forget that the CPUs and GPUs on the machine you're using are going to be shared between your Java and your model processing. And make sure you plan accordingly. So Ollama does a pretty good job of managing model memory outside of the JVM heap, but it hogs the system RAM. So that's a good example right there. So your Java will run slower, but you'll get better results in your large language model. You got to mix that and make sure you're getting the right mix with your Java allocation and your LLM allocation as well. Response time. So streaming responses, send tokens as they're generated, and basically that means that you're sort of streaming your tokens rather than saving them all up and sending them all at once. And caching prompts. So sometimes the same question will be asked of your large language model by multiple people. See if you can cache things. That's what I was mentioning before on the front end about orchestration. Make sure that you've got a good orchestration footprint in the application that calls your large language models, that does streaming, does prompt caching, and optimizes caches as well. And you can also you can do batch requests. If there's common questions that get asked daily, you can do a batch request and have those questions ready in your cache when you actually build the application as well. And then model warm-up, make sure and preload the model on startup. Cold start has penalties. A lot of the tools that you use online will scale down to 0, and that includes Kubernetes and Kubernetes-related tools. You want to make sure that you have a way of starting those up at the right time. Maybe it's acceptable that once in a while a cold start timing is okay, and that means it's less memory usage, less energy usage, and less expenses if you're actually being charged for the GPUs that you're using out on the cloud. And then make sure you're matching the hardware for the models that you want to use, basically common sense stuff. So integrating open models with LangChain4j. I'm going to show an example of this, but LangChain4j supports Ollama, VLLM, and any OpenAI compatible endpoint. So that's an important point. A lot of model providers out on the web provide you with Python, but you can use the endpoint from that Python code and you can generate LangChain4j code in Java and use that endpoint or token or key to actually access that model using Java. So, and to do that, LangChain4j has full OpenAI model SDK support. And then, by the way, that's based on contributions to LangChain4j from my colleague, Julien Dubois, who basically did the entire OpenAI implementation in LangChain4j with some support from others, but it was mostly him. So that's pretty cool. He actually developed that whole thing. So like I say, quite often you'll go out to a model provider, they have Python examples. You can just take that Python example, put it into VS Code or another code generator, and say, hey, can you translate this to Java, use LangChain4j, and the OpenAI SDK support for LangChain4j will convert it to code that'll probably work the first time, if not 2-3 iterations, and you'll be ready to use it. So that's kind of cool. So Ollama chop model is one of the classes you have. OpenAI chat model is another, and you've got tool annotations. I'm going to show an example of tool and an AI services interface, and you can swap models without changing code. So you can actually just behind the scenes change models inside of your LangChain4j implementation, but the code stays the same. So you don't have to rewrite your Java code every time you want to access a new model. LangChain4j will take care of that. And the tool annotation, just to mention, it was created before MCP tools, so it's not MCP. It's a little confusing. Model Context Protocol is a tool calling platform, but the LangChain4j tool implementation is actually a LangChain4j tool implementation, not MCP. Some people get a little confused with that. And then you've got an embedding model for vector search. I'm going to show an example of that as well, and embedding store. So, and that's with a retrieval augmented generation, RAG. Okay, so LangChain4j, code patterns for open models. You can connect to Ollama. Basically, you just set up your chat language model. You use a builder. You can connect to the base URL. Now, the default Ollama port is 11434. You can use the model name and the temperature you want. So temperature is basically based on groundedness. Higher the temperature, the more creativity the model will use, which is great if you're doing something like writing a book or text or something like that. But if you're actually trying to get real answers that are grounded in the real world, you want to have that temperature as low as possible. And then you can define a tool. So once again, that's LangChain4j tool, search the knowledge base, and then you can create an AI service with that tool. And you just send it a system message, and then the user message gets passed. So the system message can be separated from the user message. That's good security because the user doesn't provide the system message, and you can use that for preventing jailbreaks, prompt injection, and other things that go wrong with AI services. And then you choose the model using the AI services builder, and you can go with the tools, and you choose the memory that you want to use. That I mentioned before, calibrating the JVM memory with the LLM memory is important. So, running models locally with Ollama, basically you just download. If you're using Linux, you just run apt-get install Ollama, and it'll set it up for you. Ollama.com has lists of the models there, and you can pull and run any model, and you can expose an OpenAI compatible API on localhost. So that's something that's really compatible with LangChain4j as well. So you can run these locally out of the box with LangChain4j. And it handles all the things you want to do for controlling your performance, quantization, memory management, GPU, et cetera, et cetera. Supports the tool calling, but not the MCP tool calling, just the LangChain for J, and then it's ideal for development and test. Let's see. So let's actually go in and look at this. So the question was, let's find out about that. Because that's a good question. I'm going to go in here to, yeah, so there you go. So I went to Ollama.com. You're asking about Nemoton 3 Super. It's there. And it's 120 billion open experts model activating 12 billion parameters. So it's a big model. It's much bigger than pretty much anything else out there that's out there right now. It's kind of making waves in the news because this is a big model that NVIDIA just released 5 days ago in anticipation of their big annual conference this year. And it's open model that you can use for, it's open weighted, not open source. So you can actually download that and run it. I don't have that for my demo, but it's there. So you can go in here to Ollama, you can choose models that you want to use. And then what you do, let me just go back to the GitHub repo. So I've got a GitHub repo for all this, by the way. And what we do, I'll share a link to that at the end, but all we have to do for this one is to use this Java 21, Maven 3.9, and I'm using 3 different models. So I'm going to make that bigger. So Ollama pull, I'm using Llama 3.1.8, 1.8 billion. So you can see how 20 billion is a little bigger than that. I use Mistral 7 billion, and I use Nomic embed text for when I'm doing RAG. So I can list these. Let's go in and play around with this now. So I've got these loaded in my Visual Studio Code here, actually already running, but I can go in here and I can say, oh, list. Yeah, so there they are. They're, make that bigger too. See what we can get rid of here. Not that. Come on. I need a wider monitor. There we go. So we got rid of my Copilot over here because I don't think we'll be using it for this session. But yeah, so these are the 3 models I've got. I've already got them installed. I've got instructions on the repo on how to do that. And then basically I just build and run. So I did a Maven clean package and a Maven Spring Boot run. And I've already got that running over here just in the interest of time. So it's sitting there. It's waiting for us to do stuff. And I can go in here and I can just run the, let's go down, let's make this a little smaller. Yeah, housekeeping. Where's the line? Come on, where is it? Nope, okay. Yes. There we go, yeah, got it. Yeah, so that's running that. I can ask questions, so I can chat with the model, and I can just say, let's test it out. So this is running on one terminal. I'm going to switch to another terminal here and have access to all the same stuff. And I can just say, the question is, I'm sending a chat message. What is the Java record keyword? And this one takes a little while to respond. But while it's doing that, I'll show you what the code is for that. Here we go. So it goes in and let's go in. So there you go. So it actually answers you, gives a code example and a bunch of other things. And that's using the Llama 3.1.8b. So Java 21 is still in here. I need to add 26 and 25. But it's in here and it gives you an example of the code and talks about what a Java record keyword is. So it's built in, it's there, it's useful. You can see it takes a little bit of time to respond. But basically the code for that is down here, the chat controller, and you ask a question. Oops. You set up a chat assistant and a tool assistant, and there's a reason why we have both of those running, and I'll show why in a second. And then you request a parameter, so you get a user message, and you chat with the tools, and you return a message back. So that's basically all this code does. LangChain for J takes essentially care of the rest. And let's go into the second example, because what I want to show you is tool calling. So this is a good one. How many Java 21s do we have in stock? It's kind of a silly question, but you'll see this one returns very fast. And the reason why is because there's 150 units of Java 21. We better tell Oracle to up their inventory of Java 21 because it's getting low. Anyway, and now what that does is there's a tool calling, let's see here. If we look at the source, inventory tools, and basically all it does is it loads this string. So the reason why I'm showing you this is to show you that instead of going to a large language model, this question is routed to a tools endpoint and it returns a non-LLM answer. So it actually looks something up from your tool using LangChain for J, but it's not querying all of the knowledge in the known universe to find out what the inventory is. This is all the information that we have for that inventory. We don't need to store that in a large language model and retrieve it. So that's just to show you that if you set up your orchestrators right and your routers right on top of your large language models, you can have similar functionality, just a really easy class setup that goes out and gets information that doesn't need to be in a large language model. All right, so that's just a couple examples. That's showing calling a chat controller and calling a tool controller. And then what we're going to do is I'll show the RAG controller in a second, but let's talk about what that does. Okay, so that's inference with Ollama and LangChain for J. And you can swap, in the interest of time, I won't swap to Mistral 7B, but it'll give you slightly different answers because it's a totally different model. So building RAG pipelines in Java. You have an ingestion pipeline. You can load PDF, HTML, text, DBD, pretty much anything. It chunks the data using LangChain for J, so there's a chunking functionality. And then you can embed those chunks via embedding model in Ollama and Azure. In this case, we're storing them in memory. This is nothing else, so as long as this is running, the embedding model will be stored, but otherwise you can put them in a more permanent tool. For example, Microsoft, when you're working with ChatGPT, it actually stores all of your chat interactions in Postgres databases. Huge Postgres databases, and retrieves them. So anytime you've got all those chat history items on the left, those are actually stored in Postgres on Azure, and they're retrieved by OpenAI whenever you need them, and added to the context of your query. In this case, we're going to just store it in memory and retrieve it because it's kind of small stuff. And then you have a query pipeline. So you've got an ingestion pipeline, so you get the things ingested into memory, and then you can query those user queries with the same model. And you use vector similarity search to check for chunks of data inside of the vector. When you're working with large language models, inside of the large language models, all the data is pretty much stored in vectors. And this just adds another vector outside. The vector is queried first. So you take the embedding model, you put that stuff into memory, and then when you do a query on it for the pipeline, the query first checks the embedding model and sees via a search if there's anything relevant to the query inside of that embedding model. And if there is, it sends that data with your query to the model that actually is going to provide the answer. And that gives you better groundedness and better answers, basically, that are not hallucinated. So let's talk about that. Oh, we'll talk about RAG quality. Basically, that's the other word I was looking for, faithfulness. So that's basically groundedness and faithfulness is this kind of the same thing. The answer is it supported by the retrieved context. So is it real? Is it relevant to the question? Is it precise? So are the actual chunks that you retrieved relevant to the question as well? And did it use the context that it had from previous chats and from RAG to provide the right details? And was there any hallucination detection that was built in? And I'll show you an example of evaluations in a second. You can build a test set, basically, of evaluations that can be used for How much time do we have? Okay, we got a little time. Good. So you can build a test set of questions. I've got a really simple one, just 3 questions. But you could build a set with thousands of questions. That's how benchmarks are made. And basically, you just fire those questions at any new model that you've built to see what the quality is, make sure it's relevant, faithful, and the context is precise and recalled. Yeah, and you can swap out the model, any prompt change, anything like that. Just run the evaluation quick to see if it makes sense before you expose it to your users. So for that, I can go into the RAG pipeline here. And what I do is I actually just post something. This is, by the way, a Spring Boot application that runs. It's got the 8080 endpoint exposed, and it's going to ingest some documents. So which documents is it going to ingest? They are down here. Where's my code? All right. Source. Why is it not showing them? Okay, there we go. Let's see, chat controller, open models, demo application, that's not it. Document ingester, there it is. So the document ingester basically, make this smaller again. It's hard to have all this stuff going on at once. So this basically uses LangChain for J. It uses embedding model that I mentioned before, an embedding store, and it loads everything into memory for you. So it takes a segment and it loads it in, and it uses a chunk size and a chunk overlap that are preset by the Java model itself, and adds the data you have. So down here you see the results of the data, and I'll show you the data in a second. So it just says it ingested 3 documents, and the documents themselves are up here. These are the docs. So it has the Java 21 features, Kubernetes Java deploy, a little bit about Kubernetes, a deployment guide for Java applications, and it's got a Spring Boot configuration guide as well. So 3 like really simple text documents. We load those into our embedding store, and then we can start doing queries on these. So if I go back here, and I can say, what are virtual threads in Java 21? And you'll see 2 things here when I post this in. It's a little bit quicker to respond, and it gives you a nice relevant answer based on your RAG results that you have. Looks like I lied about the quick to respond. There it is. Okay, good. It's a little faster than the original question. So as you can see here, it does provide some formatting here. And this is essentially artifacts from the vector search that was done. And it just tells you a little bit about virtual threads in Java 21. It tells you about JET 444. And if we look in our documents, you can see that all that information, we didn't have to go to the large language model to get the JEP or the basic information, but it did go to the large language model to get more of a verbal description of what it does. So it used a combination. It grabbed the data from our document and it posted it to our Llama model, and then it used that to provide a response here to there. I mentioned quality as well. So there's a quality evaluation here, and I'll show you what the evaluation is in a second, but let's just evaluate the data. And so basically, again, I just go to localhost 8080 and I just evaluate. And the evaluation code, while that's running, is here. RAG Evaluator Java. So, still running? Okay. So the RAG Evaluator, there it is. So it returns data. Let me show you the code first, and then I'll show you the rest. So this actually has 3 questions. Basically, it's a really simple evaluator, and this is how you'd write your evaluator in LangChain for J. So it actually uses the embedding model, and you can pass information. It's just basically questions. They're getting passed to the large language model, and you evaluate what these questions are in terms of faithfulness. So when we look at this is the code. It checks for retrieved contents, faithfulness, relevance, precision, and the correct source. And then it gives you a value at the bottom of the query. So if we go back up here, you can see the query. It's kind of a big mess here, but this is what gets returned from the large language model. That is the first one. Here's the evaluate. So you can see here what the model, it tells you what the model is, the latency, the precision, the relevance, the accuracy, and the faithfulness, and then gives you the information about the actual retrieval of the data. So it's just a way to build your own benchmarks and evaluate your own data based on things you might need. All right, so that's a couple of examples of working with code and LangChain4j. I'll give the repo at the end. But I do want to talk about safety as well for open models, because if you go to a place like Hugging Face, which I'll show in a second, they don't include content filtering or any kind of safety built in. You have to add your own. So once again, that router or that orchestrator on top is really important. And you can add safety in your input guardrails and your output guardrails. So when you put the query into the large language model, you want to check for prompt injection. You want to check for jailbreak attempts, things like that. These are things that are generally part of a commercial large language model out there. They've all got safety and evaluation tools built in before the query gets to the large language model, just to filter out anything that it doesn't want to work with. Then output guardrails. Is the response that you've got somehow offensive or breaking rules or anything that you don't want returned from your large language model as well? So you evaluate the input and the output all the time. LangChain4j has a moderation model. So moderate is the tool command, and you can just use that to either use a third-party moderator. OpenAI has a moderation tool that you can use. It's an endpoint. You call against the endpoint and you say, hey, use your standard moderation for this particular query and check to make sure it's okay. They have a model built just for safety, so you can use that. And then Meta has a thing called Llama Guard, which is similar. And you can log flagged content for review, not return it to the user, but log it and then tell the user, hey, we don't do that here. And you can log that and review it later in case there's something that you need to do, unless it's a false positive or something like that. So you use the input filter, the model, the output filter, and then if there's anything awry there, you want to just check and escalate that through human review through logs. So production deployment, you can use virtual machines. We have on Azure a thing called Azure Container Apps. And basically that's like taking a Kubernetes cluster. You don't have to manage the Kubernetes cluster yourself. We're running it, but you can just borrow a node and you can run your stuff on a node. And you can have serverless containers. They have GPU capabilities. And I'm going to show that at the booth at 1 or 1:30 today. I've got an agent there that I'm going to run on a GPU on Azure. It's got an A100. We also have T4 Teslas as well, but I usually use the A100. It's a lot better performance. And you can scale down to 0. So I can go and borrow a GPU for 40 seconds, run whatever I'm running, and then shut it down, scale it down to 0 again. Then, of course, we have Azure Kubernetes Service, which is Kubernetes. We manage the control plane, and you manage the operation and whatever you want to do on the actual application. And the Foundry model catalog. So I'm going to show you different things. I'm going to skip through the Azure Container Apps for model hosting. I mentioned already it's got T4s and A100s. You can scale it down if you want to. AKS also has GPUs that you can use. And you can have spot instances for development. It's similar to ACA, where it scales down to 0. And we have Kita Auto Scaling, which is a CNCF project that can be used to scale your Kubernetes and or AKS. Doesn't have to be on AKS, but it can actually scale things based on loads that you have on your system. And then I always recommend Helm charts for reproducible deployments and inference servers. So Microsoft Foundry, I won't bore you with all this text here. Let's go in and we're going to actually look at some of these now. So Microsoft Foundry, this is today it's got 11,413 models. They add models all the time, including GPT-5.4 just got added. But that model I wanted to show you was a super, actually I think I've got it preloaded here. Do I? Yeah, so super's there. So that's the NVIDIA Nemotron model here. So you can download that through Ollama. You can play around with it yourself. But then once you want to move it from your local machine to something in production, you can go into Microsoft Foundry. It's ai.azure.com. And you can actually say, use this model and deploy it. So it's a Nemotron 3 Super 120 A12B, a large language model. It's huge. It's got open weights, not open models. And it's got a mixture of experts for architecture and different MOE layers that, and it's let's see, it's distinct from the nano model. So they have, NVIDIA has nano models, which are very small. This one's big, but it's still open weight and downloadable. So it has 12 billion parameters compared to 7 billion or something for Llama and the others, and 120 billion parameters in total. 12 billion active parameters means that through quantization and through MOE, there's 120 billion parameters inside the model, but 12 billion are actually being used at any time for queries. And it's slight, what happens is there's a slight cost for precision, but generally you get similar results. And it has all these spoken languages available as well. I see, I think, yeah, it was just built March 2026. And the post-training data has a cutoff date, so you've got a lot of relevant latest information. So for example, Java 25 will be in there, Java 26 might not be. And you can play around with that. And anyway, you can deploy it here, but I think I mentioned before, we have 11,000 models, but most of these models, if I go down here, come from Hugging Face. So 11,000, oh, it only shows 38, why? Yeah, so 11,000 of the models actually come from Hugging Face. You can see the number right there. I must have another filter. Oh, super. That's what I got. So 11,006 of those models are from Hugging Face. So what the heck is Hugging Face? For those of you who didn't put your hand up earlier, yeah. So Hugging Face is a place where you can get open models. And as you can see here, if you click on inference available, these are the ones that are downloadable and usable. And you can download these and use these from anywhere, or you can even deploy them. So you can go QN, and let's see, where's the deploy? There it is, deploy. So you can set this up on an inference provider, including Microsoft, oh, not that one, but I think the super one is. Let me see. Let's do this, and let's go super. I know we only have about 10 minutes left, so, or less than 10 minutes now. There it is, super. So inference available and super, there it is. So the Nemotron 3 Super 120B. So I can deploy this here, and I can deploy this. Well, I know I can deploy it to there's Microsoft Foundry. So I can deploy it there. I can do that from here or there. But the difference between Hugging Face and Microsoft Foundry is Hugging Face, you can be sure where the model came from. We verified that it came from Hugging Face and that it's a genuine model that comes from, if it says it's from QN, we know it's from QN. Whereas here, it's kind of like the Wild West. At Hugging Face, they've got all kinds of models from anybody, and you just don't know what's in those models. So that's the upside is you got all the models and you have all kinds of choices for deploying them. The downside is you really have to do some evaluation on the quality and the veracity of your model in Hugging Face. There's also GitHub models. So GitHub models, I want to show you this for sure. And GitHub models, so in Foundry, when you go up to Foundry here, when I want to use NVIDIA Nemotron 3, I deploy it. And I deploy it onto a virtual machine and or a serverless platform. So I can say use this model. And before I can use it, I have to deploy it. And then it provides me some code and stuff. GitHub models is a little bit different. These are already deployed models. You share them, they're throttled, but they're great for dev tests. So for example, once again, I can look for open weight, super, same one, I think. Hopefully, nope. Anyway, oh, did I not hit the super button? The search button. Anyway, not sure why it doesn't turn up. It's there, but Pi4, for example, is a similar one. So it doesn't have as many parameters, 5.6 billion parameters instead, but it's open weight, so you can use this as well. And instead of deploying this, you can actually just try the model here, and you can get a token. 5 minutes left. So it's, you can get a token from GitHub and an endpoint, and you can just start working with the model. You don't have to deploy it. NVIDIA has a similar thing. So NVIDIA, you can actually use build.nvidia.com. Same idea. So you can actually use, I think I have, yeah, all the same models are there. They have a really good one for parsing, which I'm going to show later on today at the booth. But Nemotron 3 Super 120B. So I can, once again, I don't have to deploy this model yet. I can deploy it from NVIDIA, but I can get a API key from NVIDIA and it point it to an endpoint. And you can work with the code there. If I go to deploy here, I can deploy it on one of these, or I can say self-hosted, and you generate an API key and you pull the code. And you can test the NIM. You can use curl for that. Also, there's all of the NVIDIA models only have Python or shell script or curl as your options to interact with them. But you can use LangChain4j. You can take the Python code, which has the endpoint in it. You add your API key, and then you can use those models to play around with things. You can ask LangChain4j. You can use LangChain4j code and or ask Copilot to generate the code for you for LangChain4j. Provide the Python code that they give as a sample. Just ask LangChain4j to translate it and run it. All right, so I'm going to wrap things up quick. I flipped over a couple of things because I mentioned at the beginning I didn't think I'd get all the way through the presentation, but I definitely wanted to make sure you had the highlight. So, Foundry Local is another one. So Foundry is a Microsoft offering. We also have something similar to Ollama. It doesn't have as many models, but it's called Foundry Local. And you can use Foundry Local to run things locally, like Super 3. Then you can use GitHub models to test things out. And then you can use Microsoft Foundry to actually deploy a model whenever you want to. So it's the same API at every tier. That's the value of having Foundry Local. So I mentioned GitHub models. I showed you how that works. BuildNVIDIA.com, similar to GitHub models, but with NVIDIA models only. Last but not least, Docker Model Runner. So Docker has its own tools for going out and getting models, but they're container-based. Let's see, Docker Model Runner. And you can run them locally. Any hub that you want, including Docker Hub, has a whole bunch of popular models you can play around with. Let's see, the models are here, I think. No. So you can take the code from the code samples in the Docker Model Runner and you can pull it into a container. So it's the same as downloading it to Ollama, but in this case you're going to use Docker, which you're already familiar with, Docker pull, to pull in the model for you to actually work with it. So that's just a slight difference. Similar to Ollama, but containerized models, and you have the Docker CLI that you can use. Observability, so GenAI applications, open telemetry is good for it. It's great to have the trace. You need to have, when you're working with complex orchestration and large language models, you definitely want to have the trace there. So configuration and rollback, that's just sort of common sense. Everyone knows version control, probably, hopefully. GenAI Java projects. You can use LangChain4j, Spring AI, Quarkus, JBang. I'll include these slides. The slides are actually in, and I showed you Copilot a little bit already. There's some pitfalls and some takeaways, and I'm just going to wrap up with the link. There it is. So definitely check out the repo, and I'll be at the booth for a while if anyone has any questions. But aka.ms/OpenGenAI has the repo, with a PDF of the slides and everything that you need in there, including those takeaways at the end that I flipped over. You can take those back and check them out. So there's some pitfalls, but the main thing is start with a small model, work your way up until you get the results you need, and don't be afraid to try out things like quantization and things like that. And use LangChain4j or Spring AI to interact with those models and prototype with the models at GitHub Models, the buildinvideo.com, Docker Runner, and AI Foundry as well. So that's it. Thanks for coming. And like I say, if you have any questions, I'll be here for a minute and then I'll be at the booth. So thanks.